In this lesson, we'll be going over gravitational force and fields. First off, let's talk about gravitational force. Gravitational force is the force of attraction between two objects at a given distance. Looking at this formula, we have mass 1, mass 2, as well as our radius as 70 kilograms, 52 kilograms, and 1.5 meters. There's also this variable, g. This variable is a constant, sort of like pi. This is the gravitational constant. It is 6.67 times 10 to the negative 11 newtons times meters squared divided by kilograms squared. Plugging all this into the formula gives us a gravitational force. If this number seems very low to you, that's because it is. The force of attraction between what looks like two humans, being 70 kilograms and 52 kilograms, is very negligible compared to the force of attraction between two planets, which are 1,000,000 times more massive and are a lot bigger. Moving on, we have gravitational fields. Gravitational fields is just the gravity on different planets or other large objects. On Earth, the acceleration due to gravity is 9.81 meters per second squared, which can also be written as 9.81 newtons per kilogram. For this calculation, we would again use g, the gravitational constant, multiplied by the mass of the planet, divided by the radius squared of that planet. So if we were to plug in the mass of Earth and its radius, it would come out to be 9.81 newtons per kilogram. The reason that it can also be 9.81 meters per second squared is so that we can use it in kinematics formulas or projectile questions. Finally, our last formula, most simple of them all, this just helps us calculate the gravitational force of a mass on different planets. So say we were on Earth and we had a 50 kilogram man standing on the surface. Calculating it would be Fg equals 50 kilograms times 9.81 newtons per kilogram. Kilograms cancel out, leaving us with newtons in our final answer, which comes out to be 491 newtons. I feel like we're warmed up enough, so let's go into the first question. Calculate the gravitational force on a 7.5 times 10 to the 3 kilograms meteor that is 4.5 times 10 to the 6 meters above the surface of the Earth, with the mass of the Earth being 5.97 times 10 to the 25 kilograms. This question is pretty simple. All we have to do is plug in these values into our gravitational force equation. So first, Fg equals 6.67 times 10 to the negative 11 newtons times meters squared divided by kilograms squared times the mass of the meteor, 7.50 times 10 to the 3 kilograms times the mass of the Earth, 5.97 times 10 to the 25 kilograms, and then divide it all by 4.55 times 10 to the 6 meters squared. Now for our answer, we want there to only be the variable n for newtons. So let's make sure that we have all of the other variables crossed out. So meters squared crossed out, as well as these kilograms. We should be good. We should get about 1.44 times 10 to the 6 newtons, of course rounding to 3 significant digits. Moving on. The planet Jupiter has a mass of 1.9 times 10 to the 27 kilograms and a radius of 7.2 times 10 to the 7 meters. Calculate the gravitational force of a 65 kilogram man on Jupiter. This may seem like a difficult question, but in reality it's not that hard. All we have to do is plug in the mass and the radius to find the gravitational field of Jupiter, and then multiply the gravitational field by the mass of the man, which is 65 kilograms, which should give us his gravitational force. So G equals 6.67 times 10 to the negative 11 newtons times meters squared divided by kilograms squared times the mass of Jupiter, 1.9 times 10 to the 27 kilograms. Everything divided by 7.2 times 10 to the 7 meters squared. Let's cross out the variables. We can cross out meters squared, and we can cross out 1 of the kilograms, leaving us with newtons over kilograms. I think that's right. For our gravitational field, we should get about 24.45 newtons per kilogram. And then for our final answer, we use Fg equals the 65 kilograms multiplied by the G, or the gravitational field of Jupiter. Kilograms cancel out. And rounding to two significant digits, we get 1.6 times 10 to the 3 newtons as our final answer. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well and hope you have a good day.